Hey guys, this is video 2 of the DDoS mitigation remote triggered black hole routes mini-series. We're going to configure a service provider VRF with a customer facing external BGP session, as well as the customer router in autonomous system 25,000, which you can see here on the left side of the screen. And once the initial customer turnup is completed, we'll demonstrate the black hole community being utilized again, as we saw in first video. So here is the route table for our VPRN 666. That's in AS 65,000 here. So we're gonna go ahead and configure the VRF on router 1. So, and just mind you, the VPRN 666, it is irrelevant to the community tag. I just used it as an example. So we're going to create the service now. And just want to try and power through this, make it a quick lab for my sanity. And modify tunnel. Okay, that should basically be the configuration for the virtual router. So you can see now we are learning routes from our internet virtual router. So now let's just go ahead and create a loopback. Okay, you can see it's there. It's a local route. So, okay, that's probably enough for there. And actually, to be able to have a black hole route inside your internet routing table, which in this case is our VPRN 666, we got to create a static route to null. So in this case, it's just a static route to black hole. So this would be step number 1 in implementing this. And I'm just using a RFC 1918 space for this, at least for my lab, which is not the RFC standard. Oops. And you can see here, there's my static route, which is a black hole static route. And that's just the same thing as doing a IP route 0000000 whatever, null 0 at the end. So now we can go ahead and create the policy. You can see there's not much going on in this router. It's brand new turn up. So first things first, I usually just want to create the prefix list that we're going to accept from the customer. So we are going to be using 125.125.0.31, and also we're going to be accepting route 123.123.123, 32 exact, and well, let's make this a longer prefix here, just in case I want to do some more playing. So here's what we're going to be importing on our eBGP session with the customer. And actually, before I get too far, let's go ahead and build the eBGP interface and the session. But this is a new link, so let's make sure that that port is going to be running smoothly here. So it's plugged into port 115. Sorry to jump around here. So let's shut this down. .1Q encapsulation, because we're going to need a VLAN tag or service delimiting, and remote access, and no, shut this. Just say alright, so our port's up. Let's go ahead and go back into our virtual router, and we're going to go ahead and create the interface. And our interface address is going to be 125.125.125 will be 0. And I'm going to create a service access. What is it? 115. Okay, so the SAP is going to be 115, which is just our port. We're going to use VLAN 250, just a random number. Why not? So there's our customer-facing interface from our virtual router. Let's go ahead and create the BGP group. And let's see, we want to do, what is it? 125, yeah, okay. Nope. And pure AS is going to be 25,000. So that should be enough for right now. Now let's go ahead and go jump back into our policy. Okay, so the prefix list is built for the customer. Let's go ahead and build the communities. So community black hole. Our members are going to be our AS number and the community tag. Then we're going to build the community no export, well-known community, no export. Now the policy statement, this is the equivalent to a route map in the Cisco world. We'll just say, well, let's build the black hole one first. 10 from community black hole. We're going to I'm going to accept. And we're going to do add a community no export. And we're going to set the next hop to the static route null that we set in our virtual router earlier. Okay, so there's a simple way to create the policy to accept the black hole community and drop the traffic, as well as add the no export well-known community to not advertise anything from that prefix. And so another thing we could do is just nest this policy as well. So there's our customer. From prefix list, we're going to accept the customer prefix list, and we can say action next policy, or we could just do from policy black hole, but we're just going to jump into the next policy. Okay, and that should be it. So now what we want to do is build the trunk interface on our AG switch here, which is not started. So we'll just give those a minute here to start. And let's see. Let's make sure our route's in there. So there's our customer facing eBGP session. And let's go back to the GPRN. Okay, so in our neighbor statement, we're going to import customer AS and the black hole as well. And this is typical, not the best way to do this. I would have used a nested policy and just made one policy with several entries, but I'm just kind of just flying through this here. So let's start the switch here. Okay, so our port is interface 01. Top queue, trunk port, and so VLAN 250 is what we chose. And interface. So interface gigabit 00 is facing the customer, so we'll make that switch port VLAN 250 and show VLAN here. So it's active and up 0. Okay, so that's probably good for now. Now let's go to the customer facing router. So no. Sorry guys, I should have started this before the lab got going here. I'll just give this a second. Okay. So at this point, we're going to go ahead and I guess let's start with the loopback. And this is the IP address of the 32 prefix that we're going to advertise and tie the route map that's going to be the black hole community to it. So this is going to be our just our /32 here. Okay, and that's here's the information on this side. So this is, we're just going to say this is a web server hanging off behind this router at the customer prem and their enterprise. And so let's bring up this BGP session. So we'll just start with a simple interface on gigabit 800. And we are customer side 1. Oops. If I phone. Yep. Okay. Okay, so there's our interface. Let's give that a second. Okay, so we can now talk to the service provider. That's a good sign. So our interface is up. So at this point now, as the enterprise customer, we're going to go ahead and build our BGP session to our provider. And let's see, we are router BGP is 25,000. Okay, and our peer is going to be 125, 125, 125, 0, and this is peer remote AS. Sorry, here jumping between different vendors sometimes gets me mixed up. And this is going to be remote AS is our provider AS. Okay. And what we want to do is neighbor 125.125.125.0. We're going to say send communities both, and also, okay, well that's a good sign. Our BGP session is up. It's working well. We want to advertise the network of our loopback, aka our web server. That's going to get DDoS here in a minute. Now let's go back and say, let's go ahead and send our BGP communities new format. Let's create our route map, black hole. Now we're going to set the community. This is going to be normally you would ask your provider for their BGP documentation, and they would hand you over some sort of document, and then you could find what communities you can use. So we got the documentation, and it tells us we need to use 666 as the black hole community in case of a DDoS attack, so we can trigger the remote black hole routes on the provider service or internet service. So there's that. Now let's go ahead and advertise. Oh, okay, so never mind. We're already advertising this. Okay, so it's up. Okay, that's good. So let's go look at our service provider router. So router 1. What do we got going on there? So they are sending us this route, and we're accepting it. So from, let's see, it's being installed. So there's R31, and there's the route from the customer. So router 666 BGP routes. So 123, 123, 123, 132. Let's see the detail on that. So as we can see, they're not tagging it with any community members, and as well as the modified attributes. There's nothing being modified on that because they haven't tagged it with anything, obviously. So now what we're going to do is, let's see if we can do this here. So router 4 here is also part of the same AS. So you can see we are learning those routes here. So let's just do it. Ping router 666. All right, and let's oops. Oh, my mistake. Now there's one last piece to the puzzle here. We are only importing routes. We're not advertising. So one thing we can do is just so we're importing routes, but this guy has no way back. Has no idea about that router in its route table except for BGP. So let's see. Just gonna create this default route here. Prefix list, default route. Yeah, so we're just gonna emulate a default originate. We're gonna export that. All right. So now let's go back to your service. BGP group customer, go into the neighbor, and there's export default route. originate. Okay, now we can go back to our customer router. Let's see with what we're getting here. Just give that 30 seconds to propagate. And while that's going down, let's go ahead and get this rapid ping going here. Okay, so okay. Oh, not running yet. Okay. I think something got messed up here. Export. Let's go look at our policy once more. Oh, it's set to family. So, okay. Let's go ahead and edit that. Well, let's see. Well, you know what? This is what we'll do. So let's go ahead and edit the route, the VPN. Now we need to have a static route in there. So static route. And family. Okay. Let's see if we're learning. Nothing yet. Okay. Alright, so now we're sending that route. Okay, now we can ping it. So that's just the normal normal troubleshooting from a service provider standpoint in the Nokia platform there. So what we're gonna do now is launch our quote-unquote DDoS here. So it's just a rapid ping. So customer on their sides, you know, they're noticing the huge traffic increase. Let's go ahead and apply that route map. So this guy, what we're going to do at this point is say router BGPs. Okay. Just gonna do route map out, advertise the black hole, and you can see this immediately stopped. So now let's go ahead and so all of these are failed attempts at the rapid ping. So the traffic's being discarded right away on the internet VRF. So let's go ahead and take a look at that route and see the modified attributes and how it's being handled by the upstream provider. Shell router. Perfect. So you can see here, this is the route. It's being learned on the table here. But what happens is we accept this community and we modify the attributes by modifying the next hop address, which is going to this static address in our route table, going to a null route or black hole null route. Traffic's being discarded, and it is also not exporting. So if our transit provider on the other side, they are not going to be receiving that prefix because we are just blocking it, completely dropping it. So yep, there you go. Sorry that kind of went on a little bit longer than I wanted it to, but now that's literally a full configuration from the service provider down to the aggregate switch in the middle somewhere, and down to the customer router at their location, enterprise service. So yep, hopefully you guys enjoyed that. Thank you.